Hi students, today we are going to be adding what we learned yesterday about the mole ratio, which comes from the balanced chemical equation, and putting that in the mole diagram, which we spent some time learning and understanding in chapter 10. So in today's lesson, we're going to start by adding the new mole ratio to the mole diagram that we already had. So I just want to start by pointing out that this is the mole diagram that we already had. We have moles in the center, and we can convert from moles to mass measured in grams, or from moles to molecules, or moles to volume. And the conversion factor for those things are written in red, connecting the boxes in each of these little tunnels. So to get between moles and mass, or mass and moles, we use molar mass. To go from moles to molecules and back, we use Avogadro's number, or 6.022 times 10 to the 23rd molecules per mole. And to go from moles to volume at STP, we use standard molar volume, which is 22.4 liters per mole. When we had actually come up with the mole diagram, we had added to this what math operation we do when we're going which direction. So what we're going to do now is I'm going to go to a new mole diagram that's going to add in, so I want you to pay close attention to this box right here, because we learned last video how to convert from moles of one thing to moles of something else. And so we're adding a new box in here, which is going to be called mole B. And it's going to be converting from moles of one thing to moles of something else. And we're going to use the mole ratio to do that conversion. So we're going to be adding what we learned yesterday and adding it to this mole diagram, which we learned in chapter 10. So here it is. All right, so in this mole diagram, what you're seeing is a few changes. First, we have added our directions and our math operations. So when we go from mass to moles, then we're going to divide by molar mass. When we go from moles to mass, we're going to multiply by molar mass. So we put in those math operations and the directions onto the tunnels. The other thing I've added is we are now calling this moles of A, and inside of this smaller box, we have moles of B. And so in order to go from moles of A to moles of B, we use the mole ratio. What this is going to allow us to do is go from the mass of A, the mass of one thing, convert to moles of that same thing, then use the mole ratio to convert to moles of something new, and use that something new's molar mass to convert over to grams. So in this way, we can do a gram A to gram B conversion. These are 4-step conversion problems. And so we are going to be just jumping in and practicing some of them using the mole diagram and also your periodic table. So if you haven't already, this is a good time to pause the video and get this mole diagram completely written down nice and neat in your notes so that you can be using it while we do our next set of problems. So now that we have our mole diagram with mole A, mole B added in the center, what we're going to do is we're going to use the coefficients of our balanced chemical equation, and we're going to add that to the grams to moles and moles to grams conversions that we learned in chapter 10. So the question's going to ask something like this. How many grams of BaCl2 are made when 4.78 grams of BaOH2 react with excess AlCl3? So the first thing that I want to point out to you guys is that you do not need to consider with excess AlCl3. That is not something that we need to consider. When it says with excess, that's telling us we can ignore this bit of information. What we do see is we're asking about grams of BaCl2. So that is our destination. And we are given grams of BaOH2. So this is our point of origin. We're going to need to be able to go from mass to moles of A, to moles of B, and back again to mass. So to start this problem, I am going to start with what I'm given as a fraction over 1. So I am given 4.78 grams of BaOH2 as a fraction over 1. So the first thing that I'm going to want to do is go from mass of BaOH2 to moles of BaOH2. So I'm going to put grams of BaOH2 on the bottom and moles of BaOH2 on the top. Now my next move here is to go from moles of BaOH2 to moles of BaCl2. BaCl2 is my B, or my second item that I want to get to. So I'm going to now convert from moles of BaOH2 to moles of the other thing I want, BaCl2. And in my last but not least equation, I am going to take my moles of BaCl2 and convert back to grams. So I'm making a big loop. So I'm going to take my moles and convert back to grams. Once I have created this list, now I need to start filling in my conversion factors. In my first fraction, I see moles over grams, and my of what is the same. That's good news. So we have 2 units in every fraction, either grams or moles, and then of what. And it's important that only one of those sets of units is changing in each fraction. So we can change from grams to moles, but we have to stay the same of what. We can change from BaOH2 to BaCl2, but then our moles have to stay the same. And again, we can change from grams to moles, but then the BaCl2 has to be the same. This is a kind of problem that has a consistent pattern. You will get used to the pattern, but I'm trying to point out all of the pieces of the pattern so you'll know how to decide if you are doing them correctly. The next thing we need to know is that when we have moles and grams in a fraction, we need molar mass. And when we have moles and moles in a fraction, we will use the mole ratio. So first up, moles and grams in the fraction, I need the molar mass of BaOH2. Remember that the 2 distributes in, so that's how we know the numbers. To find the individual values for these, we are going to look at Ba, which is over here, 137.33, O, which is 16.00, and H, which is 1.01. Feel free to use your calculator to add that up, and we'll get the molar mass for BaOH2, and then we can plug that in to our first fraction. Remember that 171.35 grams goes with the grams, and moles gets a 1. We do the same thing over here. We have grams and moles again. So this time we need to find the molar mass for BaCl2. Again, feel free to use your calculator as you go. And we end up with the molar mass of 208.23 grams per mole. Remember that every time we write the molar mass up there, the number goes with the grams. So in our first fraction, that happens to be in the denominator. In our second fraction, that happens to be in the numerator. The only thing that's always true is that it is with the grams. As for the mole ratio, in this fraction, we are going to look to our balanced chemical equation. This is the new information that we added. So as we look at our balanced chemical equation, we find BaOH2 has 3, where BaCl2 is also 3. So this mole ratio could cancel out. So when we're plugging it in, we may not plug in the 3's at all. So now in order to solve this problem, we are going to multiply everything on the top of our fraction. So I'm going to say 4.78 times, and now we've canceled these out because it's 3 over 3, so I'm going to ignore those, times 208.23. And now I'm going to divide by each thing that's on the bottom, in this case just 171.35. And I'm going to end up with 5.01 grams of BaCl2. And that is my final answer for how many grams of BaCl2 are made when 4.78 grams of BaOH2 react with excess AlCl3. We're going to do one more of these kinds of problems together. Okay, so our second problem asks what mass of aluminum chloride is needed to produce 2.76 times 10 to the 3 grams of aluminum hydroxide. So as we look back at our initial problem, it's important to understand which elements we're looking at. Aluminum hydroxide, that compound, aluminum hydroxide, that's what we're given. And what we're trying to find is aluminum chloride, this one here. So when we start this problem, we're going to start with what we're given as a fraction over 1. 2.76 times 10 to the 3rd grams of aluminum hydroxide. We're now going to move from grams to moles. So grams is going to go to the bottom and moles on top. In our next fraction, we're going to go from moles of A to moles of B. You should be sensing a pattern. So moles of AlOH3 go to the bottom, and moles of AlCl3 to the top. And last but not least, moles of AlCl3 to the bottom, and up top of AlCl3. So these are our 4 fractions to solve the problem. Now we need to find our conversion factors. So we start with our first fraction, grams and moles. In order to find the molar mass, we have Al, O, and H. I have 1 Al, 3 O's, and 3 H's. Aluminum is 26.98. Oxygen, 16.00. And hydrogen, of course, 1.01. 77.71 grams per mole, and that, of course, goes with the grams. Since we're already looking at the periodic table, we might as well find the molar mass for AlCl3. So Al and Cl, 136.33 grams per mole, so that, again, goes with the gram for 1 mole. And then last but not least, we check back on our initial problem and we find the coefficients from our balanced chemical equation, and we end up with 2 over 2. So now as we plug this into the calculator, I'm going to put in 2.76 times 10 to the 3rd, and once again my mole ratio is going to cancel here, so I don't need to plug those in. So I'm going to say times 136 times 136.33 divided by 77.71. And if I want that in scientific notation, I'm getting 4.84 times 10 to the 3rd power. And the unit for that is going to be what's left, grams of AlCl3. Now these problems can feel relatively tedious, but they have the same pattern over and over and over. You do a molar mass, you do a mole ratio, you do another molar mass, and then you solve. They're not so bad as you continue practicing them. So we will do more of these in class together on Thursday. Until then, you guys have a great day, and I will see you soon.